didn't see you there. And in this video, we're going to talk about what makes music. But before we get into that, we're going to have to first explain what sound is. Sound is a wave. We sense it when vibrations in the air are detected by our sensitive eardrums. Now, there are two kinds of waves, longitudinal and transverse. We can demonstrate both these waves with a slinky. Transverse waves are ones that move from side to side, perpendicular to the direction they're going in. Longitudinal waves, on the other hand, oscillate back and forth, parallel to the direction they're going in. Just like how this slinky compresses and decompresses as it transports the longitudinal wave, sound moves through the air when molecules bump into each other and vibrate. Now, you might have heard somewhere that the pitch of a sound is determined by its frequency. When I shorten the length of the ukulele string that vibrates, you can hear the pitch get higher. This is because the speed of the wave is equal to the frequency of the wave times the wavelength. Since the speed at which the wave travels through the string doesn't change, we know that by decreasing the wavelength, the frequency must increase in order to balance out the equation. In a closed system, both transverse and longitudinal waves can interfere with themselves perfectly, so that it looks as if the waves are just swaying back and forth in place. Because these waves don't look like they're going anywhere, they're called standing waves. The points on the standing wave that remain in place are called nodes, while the points that move the most are called antinodes. Standing waves are most present in wind instruments, especially the trumpet. Here's how a trumpet works. There are 3 finger valves, each of which, when pressed, increases the distance my air travels through the instrument and out the bell. I create vibrations throughout the pipes by buzzing my mouth against the mouthpiece, and then I lengthen the tube, which brings down the pitch of the buzzing. But if lengthening the tube was the only way to bring down the pitch, I would only be able to play 7 notes. However, I can change the shape of my lips, or my embouchure, so that my lips will vibrate faster, which also increases the frequency. The pitch doesn't change nearly as easily with the whole instrument, but if I increase the frequency enough with my lips, then I increase the amount of nodes that are in the tube, the same way I can increase the amount of nodes in the slinky. By doing this, the wavelength decreases significantly, which in turn gives us a jump up in frequency and pitch. And what's more is that I can combine the pitch shifting of the valves and the pitch shifting of my lips so that I can play all sorts of notes. And that's how you make music. Thanks for watching.